Imagine the sky over England in the summer of 1940. The sun is setting, tinting the clouds orange and red, and suddenly you hear a distant hum that quickly turns into a deafening roar. Dozens, perhaps hundreds of German aircraft are crossing the English Channel in perfect formations, their dark silhouettes against the sky. The Luftwaffe, the most powerful air force in the world at that moment, was confident. They had conquered Poland in weeks, crushed France in little over a month, and now they were coming for England. Their pilots laughed, their commanders celebrated in anticipation. They expected an easy victory, almost a stroll over enemy territory. But then something happened that no one in Germany had foreseen. Something that would change the course of the war, that would save an entire nation from invasion, and that would become an aviation legend. This something had an elegant and deadly name, Spitfire. But why was the Spitfire so special? Why did this aircraft, initially ridiculed by the Luftwaffe, become the nightmare of German pilots? The answer lies in a fascinating story of revolutionary engineering, bold decisions, and a man who saw aircraft not just as machines, but as flying works of art. This is the story of how the Spitfire's engineering was so insane, so advanced for its time, that it made the impossible a reality and defended a nation's freedom against overwhelming odds. Before we continue with this incredible story, subscribe to the channel so you don't miss any content on engineering, history and innovation, and leave a comment with the time you watch this video. Now let's dive into this fascinating journey. Let's go back in time before the epic battles, before the aerial combats that would paint the sky with trails of smoke and glory. Let's go to the 1930s, when the world was still recovering from the devastation of World War I, but already felt the storm winds approaching again. Aviation was evolving rapidly. What were once fragile wood and fabric machines were transforming into ever faster and more lethal metal fighters. And amidst this revolution, there was a man who would be instrumental in changing everything: Reginald Joseph Mitchell. Mitchell wasn't just an engineer. He was a visionary, someone who looked at an aircraft and saw possibilities others couldn't even imagine. From a young age, he was obsessed with speed and aerodynamic efficiency. He didn't just want to build planes that flew. He wanted to build planes that danced in the sky, that sliced through the air like blades, that defied the very laws of physics. And it was this obsession that led him to Supermarine Aviation Works, a British company known for its racing seaplanes. In the 1920s and early 1930s, Mitchell had worked on a series of racing seaplanes that dominated the Schneider Trophy competition, one of the most prestigious speed races of the time. These aircraft were not only fast, they were revolutionary. The S-6B, for example, reached speeds that seemed impossible at the time, breaking world records and showing the world what was possible when you combine brilliant engineering with pure aerodynamic design. And it was working on these seaplanes that Mitchell developed many of the ideas he would later incorporate into his most famous creation. But let's talk about the political and military context. While Mitchell was refining his skills with racing seaplanes, Europe was moving inexorably toward another conflict. Germany under Nazi rule was secretly rearming, violating the Treaty of Versailles. They were building a powerful air force, the Luftwaffe, and developing advanced military aircraft. England, still reeling from the effects of the Great Depression and reluctant to prepare for another war, was falling behind. The British Royal Air Force, RAF, still operated primarily biplanes, aircraft that seemed like relics of a bygone era compared to what Germany was developing. It was in this context that the British Air Ministry finally realized it urgently needed to modernize. They issued a technical specification F730, calling for a new monoplane fighter that could compete with emerging threats. The requirements were ambitious. The aircraft had to be fast, agile, armed with at least 6 machine guns, and capable of intercepting enemy bombers at high altitude. It was a huge challenge, but Mitchell saw an opportunity. Mitchell knew that to meet these specifications, he couldn't simply improve existing designs. He needed to start from scratch, apply everything he'd learned from his racing seaplanes, and create something completely new. And that's what he did. He began with the fundamental principle that guided all his work: reducing aerodynamic drag to an absolute minimum. Every curve, every surface, every detail of the aircraft would be optimized to cut through the air with the least possible resistance. The first revolutionary decision was the wing. Mitchell knew that the wing was the heart of any aircraft, the component that determined not only how much weight it could carry, but also how it would perform in flight. And he wanted a wing that was perfect. But what makes a wing perfect? Mitchell had studied aerodynamics extensively and knew that the ideal wing shape changed depending on speed and flight conditions. At low speeds, you wanted a thicker, more surface area wing to generate maximum lift. At high speeds, you wanted a thinner, more tapered wing to reduce drag. The problem was, no single wing could be ideal in all conditions, or was it? Mitchell had a brilliant and utterly insane idea for the time. What if he created a wing that changed shape along its span? A wing that was thick and robust at the root, where it connected to the fuselage and had to withstand the greatest structural stresses, but gradually became thinner and tapered toward the tips. This wing would have a different aerodynamic profile in each section, optimized for the specific conditions of that section of the wing. And to further maximize efficiency, the wing would have an elliptical planform, a shape that optimally distributed lift across the entire span, minimizing induced drag. When Mitchell presented this concept, many engineers thought he had lost his mind. An elliptical wing with a variable profile. That would be incredibly difficult to manufacture. Each wing rib would have to be unique, cut to a slightly different shape. The metal skins would have to be molded into complex three-dimensional curves. The cost and complexity of production would be enormous. But Mitchell wasn't interested in doing what was easy. He was interested in doing what was right, what was best. And he knew, he was certain in his bones, that this wing would give his aircraft a decisive advantage. And Mitchell was right. When the first prototypes flew, that elliptical wing proved to be absolutely magical. It gave the Spitfire exceptional maneuverability, allowing for tight turns that other aircraft simply couldn't match. The ideal lift distribution meant the Spitfire could fly higher and faster on the same engine than competing aircraft. And those smooth, elegant curves weren't just beautiful to look at. They reduced drag to a minimum, allowing the Spitfire to reach impressive speeds. But building those wings was a manufacturing nightmare, requiring highly skilled craftsmen and countless hours of manual labor. It was insane from a mass production standpoint, but from a performance standpoint, it was pure genius. But Mitchell didn't stop at the wing. He knew that to achieve the speeds he desired, every square inch of the aircraft had to be aerodynamically clean. This meant eliminating every protrusion, every rough joint, every irregularity that could cause turbulence. The fuselage was designed with smooth flowing lines, tapering gracefully toward the tail. The control surfaces were carefully integrated into the design. Even the rivets holding the metal skin in place were installed as flush as possible with the surface. And then there was the cockpit. Mitchell wanted to give the pilot the best possible visibility, so he designed a domed cockpit with large glass panels that offered a panoramic view. This was critical in aerial combat, where seeing the enemy first often meant the difference between life and death. But a large cockpit meant more drag, so Mitchell had to find the perfect balance between visibility and aerodynamics. The result was a sleek cockpit that blended seamlessly with the fuselage, providing excellent visibility without significantly sacrificing speed. But all this aerodynamic beauty would mean nothing without power. And it was here that the Spitfire received its heart, the Rolls-Royce Merlin engine. This engine was an engineering masterpiece in its own right, a supercharged V12 engine that produced over 1,000 horsepower. The Merlin was smooth, reliable, and, crucially, had potential for future development. Throughout the war, successive versions of the Merlin would produce increasingly more power, allowing the Spitfire to evolve and remain competitive even as new enemy aircraft appeared. But simply having a powerful engine wasn't enough. Mitchell had to integrate it seamlessly into the aircraft. The engine cooling system, for example, was ingeniously designed. Instead of simply hanging a large radiator underneath the aircraft, which would create massive drag, Mitchell placed the radiator in an aerodynamic fairing under the wing. This fairing was designed not only to minimize drag, but also to exploit the Meredith effect, an aerodynamic principle by which heated air passing over the radiator can actually generate a small amount of thrust when expelled out the rear of the fairing. It was yet another example of how every aspect of the Spitfire's design was considered to extract every last drop of performance. And then there was the propeller. Most aircraft of the era used fixed-pitch propellers, where the blade angle was permanently set. But this was suboptimal, because the ideal blade angle changed depending on speed and altitude. Mitchell specified a variable pitch propeller for the Spitfire, where the pilot or an automatic system could adjust the blade angle in flight. This allowed the propeller to operate at maximum efficiency in all conditions, extracting more power from the engine and improving both top speed and rate of climb. But here's something that makes the story even more heartbreaking and tragic. While Mitchell worked frantically on the Spitfire, he was battling an enemy no amount of engineering could defeat: cancer. In 1933, he was diagnosed with rectal cancer and underwent surgery that gave him only a few years to live. Mitchell knew he was racing against time, not only to develop the aircraft England needed, but to see it fly before it was too late. He worked with an almost manic intensity, often ignoring medical advice to rest. Every drawing, every calculation, every design decision was imbued with urgency. Mitchell wasn't just building an aircraft. He was building his legacy, his last and most important contribution to his country. And on March 5, 1936, the magical moment Mitchell had dreamed of occurred. The first Spitfire prototype took off from Eastleigh Aerodrome for its maiden flight. Test pilot Captain Joseph Mutt Summers took the aircraft into the skies and immediately realized he had something special on his hands. The Spitfire was responsive, agile, and fast, incredibly fast. When Summers landed after the test flight, he walked up to Mitchell and simply said something like, "Don't change a thing." It was the highest compliment an aircraft designer could receive from a test pilot. The Spitfire needed no significant adjustments. He was right from the start. Mitchell had the joy of seeing his creation fly, of knowing he had succeeded. But tragically, he would not live to see the Spitfire in combat, to witness how his aircraft would save England. Reginald Mitchell died in June 1937, at the age of 42, less than 18 months after the Spitfire's first flight. He died without knowing that his aircraft would become a legend, without knowing that thousands of pilots owed their lives to his brilliance, without knowing that he had helped save Western civilization from tyranny. But the Spitfire's story was just beginning. After Mitchell's death, the Supermarine team continued refining the aircraft, preparing it for mass production. And it was then that the true insanity of the Spitfire's engineering became apparent. That beautiful elliptical wing, those perfect curves, all that aerodynamic optimization came at a cost. The aircraft was extremely difficult to manufacture in large quantities. Each Spitfire required thousands of hours of skilled labor. The wings especially were a monumental challenge. Every rib had to be individually cut. Every metal skin had to be carefully shaped and fitted. No two ribs on the entire wing were identical. For a factory accustomed to mass production with interchangeable parts, this was a logistical nightmare. But England had no choice. They needed Spitfires no matter how difficult they were to build. Factories were established, workers were trained, and slowly the pace of production increased. But it was never going to be easy. Throughout the war, the Spitfire remained a complex aircraft to build, requiring craftsmanship beyond simple manufacturing. In contrast, aircraft like the Hurricane, which also defended England, were much simpler to mass produce using more traditional construction methods. But the Hurricane never matched the Spitfire's performance. Mitchell had chosen the difficult path because it was the path that led to excellence. And then came 1939, and the war everyone feared finally began. Germany invaded Poland in September, and England and France declared war. But during the first few months, there was relatively little fighting in the West, a period that became known as the Phony War. But that would change dramatically in the spring of 1940. In May, Germany launched its blitzkrieg against France and the Netherlands. The speed and ferocity of the attack were shocking. Within weeks, France, which had resisted for 4 bloody years in World War I, was on the brink of collapse. The British Expeditionary Force had to desperately evacuate Dunkirk. And suddenly England was alone, the last democratic power in Western Europe still holding out against Hitler. The Luftwaffe had dominated the skies over Poland and France, destroying enemy air forces with apparent ease. Their pilots were experienced, many having fought in the Spanish Civil War. Their aircraft, especially the Messerschmitt 109 and the Bf 109, were considered among the best in the world. And the German commanders were confident, perhaps even arrogant. They had conquered most of Europe in a matter of months. England would be just another victim. But the Germans made a crucial mistake. They underestimated the Spitfire. German intelligence reports about the aircraft were inconsistent and often inaccurate. Some reports acknowledged it was a formidable aircraft, but others dismissed it as not a serious threat. German pilots who had engaged Hurricanes over France frequently reported superiority, and many assumed the Spitfire would be no different. It was an assumption that would prove fatal. In July 1940, the Battle of Britain began. The German objectives were clear: destroy the Royal Air Force, establish air superiority over the English Channel, and then launch Operation Sea Lion, the invasion of England itself. Hermann Göring, the commander of the Luftwaffe and one of the most powerful men in the Nazi regime, was confident. He had promised Hitler that the Luftwaffe would crush the RAF within weeks. The first waves of German attacks targeted shipping convoys in the Channel and coastal ports, testing British defences. It was in these initial engagements that German pilots had their first real encounter with the Spitfire in significant numbers. And what they discovered shocked them. The Spitfire wasn't just good, it was exceptional. It was faster than the Bf-109 in many flight regimes. It was more maneuverable, capable of tighter and faster turns. At medium and high altitudes, where many of the combats took place, the Spitfire had the advantage. And that elliptical wing, that insane design that had been so difficult to build, gave British pilots a maneuverability that the Germans simply couldn't match. But the Bf-109 had its own advantages. It could dive faster, thanks to its direct fuel injection system, whereas the early Spitfire, with its carburetor, suffered from momentary engine failure in negative dives. The Bf-109 also had better visibility in some directions due to its cockpit design. But overall, especially in the hands of a skilled pilot, the Spitfire was at least equal, if not superior. German pilots quickly developed a healthy respect, even fear, for the Spitfire. They learned to identify it from a distance by its distinctive silhouette, especially those unmistakable elliptical wings. And when they spotted Spitfires, they knew they were in for a serious fight. Stories of German arrogance and mockery began to fade, replaced by sober accounts of a formidable enemy. It's important to note that the Spitfire didn't fight alone in the Battle of Britain. The Hawker Hurricane, though less famous, actually shot down more German aircraft during the battle, simply because there were more Hurricanes available. The Hurricane was a solid and reliable aircraft, easier to fly and maintain, and absolutely vital to British defence. But the Spitfire had a special role. It was the fighter that engaged the Bf-109s, freeing the Hurricanes to attack the German bombers with less interference. It was a strategy that worked. As July turned into August, the battle intensified. The Germans shifted focus, beginning to attack RAF airfields, radar stations, and aircraft production facilities. It was a strategy that made sense. If they could destroy the RAF on the ground, eliminate its ability to produce new aircraft, and disrupt its command and control system, air superiority would be theirs. The attacks were relentless. Waves of bombers, escorted by fighters, crossed the Channel daily, and daily RAF pilots took off to intercept them. The ensuing dogfights were chaotic and deadly, the sky filled with aircraft spinning, diving and firing. Smoke trails marked the blue British summer skies. Burning aircraft plummeted to earth. Parachutes opened, some carrying pilots to safety, others to capture or death. Spitfire pilots quickly became experts at exploiting their aircraft's unique capabilities. They learned to use the Spitfire's superior maneuverability in close combat, turning within the circle of the Bf-109s and securing firing positions. They learned to utilize the Spitfire's high-altitude characteristics, climbing above the Germans and attacking from above. And they developed tactics and techniques that maximized the Spitfire's strengths while minimizing its weaknesses. An often overlooked aspect of the Spitfire's superiority was its supporting technology. The British had developed Chain Home, a network of radar stations along the coast that could detect German aircraft approaching across the Channel. This gave the British precious time to launch their fighters and position them for interception. Without radar, the RAF would have had to maintain constant patrols, exhausting pilots and aircraft. With radar, they could conserve their forces and employ them with precision. The Spitfire may have been the sword, but radar was the eyes that guided that sword. And then there was the command and control system. The RAF had developed a sophisticated system to coordinate its defenses, with operations rooms where officers could track all friendly and enemy aircraft, directing squadrons to where they were most needed. It was a level of coordination the Luftwaffe simply didn't have. Spitfire pilots weren't just flying superior aircraft. They were part of an integrated system that multiplied their effectiveness. But let's talk about the pilots themselves, because no amount of brilliant engineering would mean anything without the brave men to fly those machines. The pilots who defended England came from everywhere. There were Britons, of course, but also Poles who had fled the occupation of their country, Czechs, Canadians, Australians, New Zealanders, South Africans, and even some Americans who volunteered before the United States entered the war. They were known as the Few, a nickname that would come from Winston Churchill's famous statement, "Never in the field of human conflict was so much owed by so many to so few." These men faced terrible odds. In August 1940, at the height of the battle, a new fighter pilot's life expectancy could be measured in days or weeks. They took off multiple times a day, facing numerically superior enemies. They saw friends die, saw aircraft explode, saw men burn. And then, if they survived, they took off again. The fatigue was constant, the stress unimaginable. But they kept going, and the Spitfire gave these men an edge. Pilots quickly fell in love with the aircraft. They loved its responsiveness, how it seemed to be an extension of their own will. They loved its speed and agility, and they trusted it. Knowing you were flying the best fighter aircraft available, that you had every advantage engineering could provide, made a difference. It gave you confidence, and in aerial combat, confidence could mean the difference between life and death. But the Spitfire also had its quirks and challenges. The controls were heavy at high speeds, requiring considerable physical strength to maneuver the aircraft aggressively. The landing gear was narrow, making the aircraft prone to pitching or rolling over during difficult landings, especially in inexperienced hands. And that carburetor problem, where the engine would momentarily misfire during negative maneuvers, was a real drawback, until it was eventually resolved with an ingenious modification. But these problems were minor compared to the advantages. And as August progressed, it became clear to the Germans that they had seriously underestimated both the aircraft and the men who flew them. German losses were mounting. RAF airfields, despite heavy attacks, remained operational, and the Spitfires and Hurricanes continued to appear day after day to contest each German raid. Goering was growing frustrated. He had promised quick results, but the RAF refused to die. He changed strategy again, this time making a mistake that would be disastrous for Germany and life-saving for England. In September, in retaliation for a British attack on Berlin, Hitler ordered the focus of bombing to shift from military targets to London and other cities. The Blitz, the bombing of British cities, had begun. From a humanitarian perspective, the Blitz was terrible. Thousands of civilians died. Entire neighborhoods were destroyed. The suffering was immense. But from a military perspective, it was a colossal mistake on Germany's part. By ceasing to attack RAF airfields and factories, the Germans gave the British time to recover, repair damage, and rebuild their forces. The RAF, which was on the verge of exhaustion, was able to breathe. And when the German bombers came to London, the Spitfires and Hurricanes were there waiting for them. The great aerial battles over London in September 1940 were spectacular and terrifying. Hundreds of aircraft clashed in the skies above the capital. The population on the ground watched, cheering when German planes crashed, horrified when British planes landed. And slowly, inexorably, the tide was turning. German losses continued to mount. They were losing bombers faster than they could replace them. Experienced fighter pilots, whom Germany could ill afford to lose, were being shot down over enemy territory and captured or killed. And perhaps most importantly, their will was failing. German pilots were exhausted and demoralized. They were no longer fighting a short, victorious campaign. They were in a war of attrition, and they were losing. By September, it became clear that Germany would not achieve air superiority. And without air superiority, Operation Sea Lion, the invasion of England, was impossible. You can't launch an amphibious invasion when the enemy controls the skies and can bomb your ships and troops with impunity. In October, Hitler postponed the invasion indefinitely. The Battle of Britain was won. England would survive, and the Spitfire had played a crucial role in that victory. Not alone, not by any means. The hurricanes, the pilots, the radar, the command and control system, the courage of the British people, all of it was vital. But the Spitfire, with its insane engineering and exceptional performance, had given British pilots the tool they needed. It had leveled the playing field against the Germans. It had shown that England was not defenseless, that they could fight and win. But the Spitfire's story didn't end with the Battle of Britain. On the contrary, it was just beginning. Because one of the most remarkable things about the Spitfire's design was its ability to evolve. Throughout the war, the Spitfire underwent constant improvements and upgrades. New engines were installed, producing more and more power. New armaments were added, from machine guns to cannons. The structure was strengthened. The wings were modified. New variants were developed for different roles. By the end of the war, there were over 20 major Spitfire variants, each more capable than the last. The Spitfire Mark I, which fought in the Battle of Britain, had about 1,000 horsepower and a top speed of about 400 miles per hour. The Spitfire Mark 24, one of the last variants, had nearly 2,400 horsepower and could exceed 400 miles per hour. It was practically a different aircraft, but still recognizable as a Spitfire, still retaining that fundamentally brilliant design that Mitchell had created. This capacity for evolution was in itself a testament to the genius of the original design. Many World War II aircraft quickly became obsolete as technology advanced. But the Spitfire had been designed with such a margin of safety, with such a robust structure, despite its delicate appearance, that it could accommodate increasingly powerful engines and increasingly heavy armament. It was as if Mitchell, even without knowing exactly how the war would unfold, had created a platform that could grow and adapt to any challenge, and the challenges kept coming. When Germany introduced the Focke-Wulf 1900, a formidable fighter that surpassed the earlier Spitfire variants in many respects, British engineers responded with improved versions of the Spitfire that could compete. When the war moved to North Africa, the Mediterranean, and eventually Western Europe after the Normandy invasion, the Spitfire was there, adapted for each theater of operations. Specialized versions were developed. There were photo reconnaissance Spitfires, unarmed but equipped with cameras and capable of flying high and fast over enemy territory to gather vital intelligence. There were naval Spitfires called Seafires, adapted for carrier operations with tail hooks and a reinforced structure. There were low-altitude Spitfires, optimized to intercept German fighter bombers flying over the English coast. The aircraft's versatility seemed limitless, and in every theater, in every role, the Spitfire earned the admiration of its pilots. Pilots from other Allied air forces often considered assignment to a Spitfire squadron a prize. The aircraft had a reputation, almost a mystique. It was the aircraft that had saved England, the aircraft that continued to evolve and triumph, the aircraft that seemed to embody the spirit of endurance and excellence. But let's get back to that engineering madness, because there's more to it. One of the things that made the Spitfire so effective, yet so complex, was its attention to detail at every level. Consider, for example, the weapons system. The early Spitfire was armed with 8 .303 caliber machine guns, 4 on each wing. This may not seem particularly special until you realize that all 8 guns had to be aligned to converge on a specific point ahead of the aircraft, usually about 230 meters away. This required precise adjustments of each gun mount, a laborious process that had to be repeated every time the guns were removed and reinstalled. But harmonizing the weapons was only the beginning. The ammunition system was complex, with belts of ammunition feeding each weapon through chutes inside the wing. These chutes had to be perfectly aligned and smooth, or the weapons would jam. And in an aircraft where every cubic centimeter of space was precious, fitting all those weapons, ammunition, and feed mechanisms within those slender wings was a feat of packaging engineering. Later versions of the Spitfire replaced some or all of the machine guns with cannons, typically 20mm Hispano cannons. These were even more difficult to install and maintain, but provided far greater firepower, capable of destroying enemy aircraft with just a few hits. The engineering required to integrate these weapons into the wing structure, to cope with recoil when fired, and to ensure reliable ammunition delivery was immense. And then there was the fuel system. The Spitfire had fuel tanks in several locations, in front of the cockpit, and in some versions also in the wings. The system had to ensure reliable fuel flow in all flight attitudes, including during violent maneuvers, where G-forces could cause fuel to flow away from the pump inlets. Ventilation systems had to prevent vacuum or pressure buildup in the tanks. And everything had to be leak-proof, because a fuel leak in combat could be fatal. The complexity extended to the electrical system, the hydraulic system that operated the control surfaces and landing gear, the oxygen system that enabled high-altitude flight, and the heating system that kept the pilot comfortable at altitudes where temperatures could drop well below freezing. Each of these systems had to be designed to be as light and compact as possible, while still being reliable and effective. It was a constant balancing act, always trying to add capacity without adding weight or drag. And this brings us to another aspect of the Spitfire's engineering madness: weight. Mitchell was obsessed with keeping weight down because he knew every extra pound detracted from performance. A heavier aircraft accelerated slower, climbed slower, and turned slower. So every component was examined for weight-saving opportunities. Structures were designed to be exactly as strong as needed, no more, no less. Materials were chosen for optimal strength-to-weight ratios. Even bolts and rivets were evaluated. But this obsession with weight had a dark side. The Spitfire lacked armor to protect the pilot in early versions. There were no self-sealing fuel tanks, which could automatically seal if punctured. These emissions were acceptable in racing aircraft, but in combat they could be deadly. A Spitfire pilot was vulnerable to rear-end fire, where bullets could puncture the fuel tank and turn the aircraft into a ball of flame. Combat experience in the Battle of France and the early days of the Battle of Britain made this painfully clear. Pilots were dying not because their Spitfires were inferior in performance, but because they were vulnerable to damage. The problem was especially acute when facing Bf-109s equipped with 20mm cannons. A single cannon hit could be devastating. The RAF responded by adding armor behind the pilot's seat and bulletproof glass to the windshield. Self-sealing fuel tanks were installed. These modifications added weight, of course, and performance suffered marginally, but they saved lives, and pilots were much more willing to fight aggressively when they knew they had some protection. It was a compromise that had to be made, a recognition that the pursuit of absolute lightness could not come at the expense of pilot survival. But even with these modifications, the Spitfire remained remarkably light for its capabilities. This was a testament to the design's efficiency, clever use of materials, and relentless obsession with drag reduction. And this efficiency paid off in performance that remained competitive throughout the war. Now let's talk about something that's often overlooked when discussing military aircraft: aesthetics. The Spitfire wasn't just functional, it was beautiful. Objectively, dazzlingly beautiful. Those flowing lines, that elliptical wing, that predatory elegance, all combined to create an aircraft that looked fast even when stationary. And this beauty wasn't accidental, it wasn't merely cosmetic. It was the physical manifestation of pure aerodynamic principles. Mitchell believed that if an aircraft looked right, it would probably fly right. He had an eye for elegant lines that was not just artistic, but functional. Those curves weren't decoration. They were the expression of optimized airflow. That slender fuselage wasn't fashion design, it was drag reduction. The beauty of the Spitfire was the beauty of mathematics rendered in metal, the beauty of perfect function. And this beauty had a powerful psychological effect. For the British, the Spitfire became a symbol of resilience, of refusal to surrender, of British quality and ingenuity. Seeing a Spitfire glide through the sky was comforting. It was a reminder that England had the tools to defend itself. For the Germans, the Spitfire became a symbol of their failure to conquer England, a painful reminder that they had underestimated their enemy. Propaganda on both sides recognized the iconic power of the Spitfire. The British featured it on posters in newsreels everywhere. Funds were raised to purchase Spitfires, with communities, businesses, and even individuals contributing. There was the Buy a Spitfire concept, where donations paid for the construction of specific aircraft bearing the donors' names or messages. It was a way to involve the public in the war effort, to make everyone feel part of the defense. The Germans, on the other hand, tried to downplay the Spitfire in their propaganda, claiming it wasn't as formidable as reported. But their own pilots knew the truth. In post-war memoirs and interviews, German pilots consistently expressed respect, even admiration for the Spitfire. They knew they had faced an exceptional aircraft flown by brave men. As the war progressed and new theaters opened, the Spitfire continued to prove its worth. In the Mediterranean, Spitfires based on Malta, that small besieged island in the middle of the sea, defended against overwhelming odds, helping to ensure Malta's survival as a vital base for Allied operations. In Burma and the Pacific, Spitfires fought the Japanese, albeit with mixed success against aircraft like the Zero, which had its own unique advantages. In Europe after D-Day, Spitfires provided air cover for Allied troops advancing through France, Belgium and into Germany. They fought against the last and most desperate German defenses, including the Me-262 jets, the world's first operational jet aircraft. And even against these revolutionary jets, Spitfires could compete in certain flight regimes, especially in tight-turning combat where raw jet speed was less important. And then, finally, in May 1945, the war in Europe ended. Germany had surrendered. The threat that had led to the creation of the Spitfire had been defeated, and the Spitfire, which had begun as the dream of a visionary engineer, had played a crucial role in achieving that victory. But even after the war, the Spitfire continued to serve. Many nations around the world operated Spitfires, including France, Italy, Egypt, India, and many others. The aircraft remained in military service in some places until the 1950s, and when it finally retired from military service, the Spitfire found new life as a racing aircraft and in air displays. Today, decades after the last Spitfire retired from military service, the aircraft remains one of the most recognizable and beloved in history. Restored Spitfires fly at air shows around the world, delighting crowds with their graceful aerobatics and the unmistakable sound of the Merlin engine. Collectors pay millions to own and maintain these flying pieces of history. Museums proudly display Spitfires, often as centerpieces of their collections. But why does the Spitfire continue to resonate so powerfully even now? Why has this aircraft, among so many that fought in World War II, captured the imagination so completely? Part of it, surely, is the role it played at a crucial moment in history. The Battle of Britain was truly a turning point. Had England fallen, the course of the entire war would have been different. Resistance against tyranny might have faltered, and the Spitfire was there at the center of that struggle, making victory possible. But there's something more, something about the Spitfire itself. It's the combination of technical excellence and beauty. It's the story of a man, Reginald Mitchell, who created something transcendent despite struggling with his own mortality. It's the fact that the aircraft was so difficult to build, so complex, so committed to perfection over practicality, and yet it worked brilliantly. The Spitfire represents a design philosophy that is nearly extinct in the modern world. Mitchell didn't settle for good enough. He didn't settle for easy solutions. He relentlessly pursued excellence, even when it was most difficult, most expensive, most complex. And he proved that this approach could work, that it was possible to create something that was simultaneously the most technically advanced and the most aesthetically beautiful. The Spitfire's engineering was insane because it refused to compromise where others would accept. That elliptical wing, so difficult to produce, so expensive, so laborious, but absolutely right. That fanatical attention to every aerodynamic detail, even when it meant extra hours of manual labor. That confidence that doing the right thing, even when difficult, would eventually pay off, and it paid off in ways Mitchell could never have fully anticipated. The Spitfire didn't just help win a battle or even a war. It became a symbol, an inspiration, proof that brilliant engineering combined with noble purpose can achieve the extraordinary. Every time someone sees a Spitfire, whether in a museum or flying at an air show, they are seeing a reminder that humans are capable of creating wonderful things when they combine knowledge, skill, determination, and vision. The Spitfire's story teaches us that excellence is worth pursuing. It teaches us that thoughtful design and careful engineering make a difference. It teaches us that beauty and function are not opposites, but can be the same when done correctly. And it teaches us that even in the face of overwhelming odds, even when the world seems to be falling into darkness, that small group of dedicated people with the right tools can make a difference. The pilots who flew the Spitfire in the Battle of Britain often said they were fighting not just for their country, but for civilization, for freedom, for the right to live without tyranny. And the Spitfire was the tool that made that fight possible. It couldn't win the war alone, of course. Wars are won by people, by strategy, by courage, by sacrifice. But tools matter. And having the best tool possible, crafted with such care and skill, gave those pilots an advantage that saved lives and helped achieve victory. Reginald Mitchell never fully understood the impact of his creation. He died believing he had created a fine fighter, hoping it would serve his country well. He could not have imagined that his aircraft would become a legend, that it would be remembered and celebrated generations after his death, that children would make models of it, that adults would pay to see one fly, that historians would write volumes about it. But in a way, maybe he knew. Maybe when he saw that first prototype take off, when he heard that test pilot say, "Don't change a thing," maybe in that moment he knew he had created something special, something that would transcend his own time, something that would be his last and greatest contribution to the world. The insanity of the Spitfire's engineering wasn't in being overly complex for complexity's sake. It was in refusing to accept limitations, in pursuing the ideal design even when it was difficult, in believing that perfection was achievable and worth pursuing. And this insanity proved to be the most profound sanity of all, because it created something lasting, something important, something that mattered when it mattered most. So when the German pilots finally stopped jeering and started respecting, when they saw those elliptical wings slicing toward them and knew they were in for a real fight, they were witnessing the triumph of vision over expediency, of excellence over adequacy, of a man who refused to conform and so changed the world. And that, in the end, is the true story of the Spitfire. It's not just about an aircraft, extraordinary though it was. It's about what humans can achieve when they refuse to accept limitations, when they pursue their dreams with total dedication, when they combine art and science, beauty and function, vision and skill. It's a story about doing the right thing, even when it's the hard thing. It's a story that still resonates today, that still inspires, that still reminds us that excellence matters and that striving for perfection, even knowing we may never fully achieve it, is a journey worth taking. The sky over England is no longer filled with the sound of Merlin engines in combat. The battles the Spitfire fought are now history, studied in books, remembered in monuments. But the spirit that created the Spitfire, that refusal to accept less than the best, that belief that excellent engineering combined with noble purpose can change the world, that spirit is still alive. It still needs to be alive because we face new challenges, new problems that demand brilliant solutions. And if we can learn anything from the Spitfire's story, it's that when we commit to excellence, when we refuse shortcuts, when we pursue perfect design even when it's difficult, we can create things that not only solve problems, but inspire generations. This story of the Spitfire shows us that sometimes, when we face the greatest challenges, when the odds seem impossible, is when the combination of human talent, determination, and faith in something greater than ourselves can create miracles. Reginald Mitchell, in his brief life, left a legacy that transcended generations. And perhaps in moments of reflection, we can recognize that along with all the human effort, all the brilliant engineering, all the courage of the pilots, there was something else guiding those historic events. As many of those pilots who flew the Spitfire testified in their memoirs, there were moments in the skies over England when they felt they were not alone, that something beyond their own abilities protected them. And in their gratitude, many thanked the Lord God for having survived another day, for having the opportunity to defend their homeland, and for having in their hands such an extraordinary machine as the Spitfire. The Spitfire's story is ultimately a story about the best of humanity, our ability to create, to innovate, to sacrifice for something greater, and to never give up even when all seems lost. It's a reminder that excellence matters, that doing the right thing is worthwhile, and that each of us in our own field can pursue that same relentless pursuit of perfection that Reginald Mitchell embodied. The Spitfire flew, fought, and won, and its legacy continues to inspire all those who believe that the extraordinary is possible when we combine vision, skill, determination, and faith.